In this problem, we want to determine all the vertical and horizontal asymptotes of this piecewise function. So f of x equals 4x divided by x minus 4 when x is less than 0. And then we have x squared minus x squared divided by x minus 2 when x is between 0 and 2. And we have cosine of x divided by x plus 1 when x is greater than 2. So we're going to start off by trying to find any vertical asymptote. So let's look at the first function. So we set the denominator equal to 0. So you'll see that you'd have a vertical asymptote at x equals 4, but this is not in the domain of the function, because it's only when x is less than 0. Then we have the middle function, so we have x minus 2 equal to 0, so we add 2 to both sides. So we have x equals 2. But here you'll end up with the vertical asymptote when x equals 2. And here it is actually when x is between 0 and 4, when x is greater than 4. So this is a vertical asymptote. Then you have the third part of the function. So x equals negative 1 is not part of this domain. So this is the only vertical asymptote we have for this function. Now to find the horizontal asymptotes, you want to check out the functions at the end. So we're going to check out the limit as x approaches negative infinity of this function, and the limit as this approaches infinity, as this approaches positive infinity. So we have the limit as x approaches negative infinity of x minus 4 on the bottom, and 4x divided by x minus 4. So here multiply top and bottom by 1 over x. So we have the limit as x approaches negative infinity of 4, and in order to have 1 minus 4 over x. So this will go to 0, so we have 4 divided by 1, which is just 4. So this is the horizontal asymptote. So y equals 4, and then the other limit. So the limit as x approaches infinity of cosine of x divided by x plus 1. Cosine of x is bounded by the function of x plus 1. So you look at it like this, so negative 1 over x plus 1 bounds the function. So the limit, we are only looking at the limit as x approaches infinity, so you only want to find the limit as this approaches infinity. So the limit as x approaches infinity of 1 over x plus 1. Here, if you do the same thing as before, by multiplying 1 over x, you'll have, or you don't have to do that for this one actually. So as the denominator goes further and further out, you're going to get smaller and smaller values, so it's going to be closer to 0. So you have another horizontal asymptote at y equals 0. So just make sure you put them together. So vertical asymptote at x equals 2, and horizontal asymptotes at y equals 4 and y equals 0.